Hello everyone, in this video we're going to talk about searching, and we're going to talk about binary searching in this video. So if you've seen our previous video on searching, we talked about linear search, and if you haven't looked at that, I would suggest to look at that one first because that's a little bit more simple and straightforward. This is a little bit more advanced as far as searching goes, but let's go into it. So we've got a different data set here this time. We're using 7 different elements, similar to our previous video, but you'll notice there are different numbers to start with, and you might also notice that there's a pattern. So you can see 3, 5, 8, 12, 20, 25, and 30. They're all going up. So they're going up in ascending order, and we could say that all these list of elements, or this array of numbers, is sorted, which it is, and that's a prerequisite for binary search, or it has to be something that's performed before we can actually do a binary search. If we had the list of elements that we had in our previous video for linear search, we wouldn't actually be able to perform this operation because we just wouldn't be able to get our desired answer, because this is not the way binary search works. So let's go and pick a number, like let's say the number 25, and we know that 25 is in this array, so we want to find out if it's true or false. So by looking at this, we can go and look at the middle point. So the middle point in this would be the number 12, because there's 3 this side and there's 3 this side. Now there could be 50 one side and there could be 50 the other side, but we pick our number in the middle, roughly. If it's an even number, there's obviously going to be slightly more numbers on the right or the left, or slightly more numbers on the left than the right, but in most cases we get the middle number, and we check to see if this middle number, which is 12, we want to check to see is it bigger or smaller than our number that we're looking for. So we know the number 12 is smaller than the number we're looking for. So since this is ordered, we can basically rule out everything to the left of 12, including the number 12 itself. And we know that our answer, if it exists, is somewhere over here in these 3 blocks. And once we get to these 3 blocks, we then change the number we're looking at to the middle of these 3 blocks. So we change this to the number 25. And now we go and we check to see, is 25 equal to this number? And it is. So we can say this is true. Now, this is actually much faster than linear search, and this is why if you want your algorithm to perform in a relatively quick time, you would want to perform binary search rather than linear search. Now, as you can guess, it's not always possible. Your elements won't always be sorted. So let's move on to our next example, which would be to look for the number 2, let's say. And we want to see does 2 exist in this array. So I'm just going to get rid of these arrows and lines, and we're going to do the exact same thing that we done last time. So we're going to look at 12 because 12 is our middle number, and we want to see if our number that we're looking for, which is 2, we want to see is that lower or greater than the number 12. And we also want to check to see is it equal, because if it's equal, then we've found our solution. But in this case, it's not equal and it's not higher, it's lower. So we know that if our element exists, that it exists in one of these 3 different numbers. And then we go to the number 5 here, because we've got 3 numbers, so we pick the middle number, which is 5, and we check to see if 2 is equal, it's not, if it's greater than, it's not, or if it's less than 5. And in this example, 2, our given number, is less than 5. So we can then rule out all numbers to the right of 5, which in this case is only one number, it's only 8. And we can also rule out the number 5 itself. So now we're only left with one element, and since we're only left with one element, we only need to check if it's equal. So it's not actually equal to our number that we're looking for, which is 2. So we would then return false. Now, if this was a longer array and there was more numbers to the left of 3, we would say, okay, it's not 3, it's less than 3, so it's to the left. But since there's nothing to the left of 3, we would then return false, meaning that it doesn't exist in our array. Again, similar to our last video, I'm going to go through the complexity analysis of our binary search algorithm. It's big O of log of n. Now, you might be thinking, okay, in our linear search algorithm, we had n. Now, in this one, we have log of n. Does it really matter? It does. It's actually a lot more efficient. And again, I'm going to encourage you to go to our complexity analysis videos if you're unsure of what this log of n means, or you're unsure about big O in general. I'm not going to go into detail in this video because I want this video to just look at searching and binary search